Hey team, today we're answering one deceptively simple question, and the answer takes us straight through relational databases on Amazon Web Services, RDS and Aurora. By the end of this video, you'll know exactly when to pick Amazon RDS, when to pick Amazon Aurora, and, most importantly, when multi-as is the right answer versus a read replica. That last distinction is the one engineers get wrong constantly, and it's the difference between a customer seeing a brief retry and a customer getting double charged during a failover. Quick callback before we dive in. Back in episode 3, we covered availability zones, physically separate data centers inside one region, and the multi-AZ deployment pattern is the production default for surviving an AZ outage. In episode 7 on shared responsibility, we saw that RDS sits one step up the ladder from EC2, with Amazon Web Services handling the engine patches. And Nexa Retail's Oracle replatform from episode 5 was the example. They moved Oracle onto RDS specifically to offload that patching work. Today we go deep on the database side of that picture. 5 terms to pin down before we start. Amazon RDS is Amazon Web Services' managed relational database service. 6 engines. Amazon Web Services handles patching, backups, and failover. Multi-AZ deployment you already know from episode 3 on regions and availability zones, so we'll just see how RDS puts it to work here. A read replica is something different. An asynchronous, read-only copy used to offload select queries from the primary. Amazon Aurora is Amazon Web Services' cloud-native MySQL and PostgreSQL compatible engine that stores 6 copies of your data across 3 availability zones. And Aurora Serverless v2 is an on-demand, auto-scaling configuration of Aurora that scales capacity in half a CU increments and bills you per second. Here's the scenario. Code Gorillas is in a scoping meeting for a new e-commerce client, and the architect has 30 minutes to decide which relational engine to recommend. Pick wrong, and you're looking at months of migration pain 6 months from now. 2 services are on the table, Amazon RDS and Amazon Aurora, and there's one subtle failover behavior that, if you miss it, can cause a customer to get double charged when the database swings over to its standby. Let's make sure that doesn't happen. Here's the mental model to anchor everything that follows. RDS runs 6 familiar engines you've heard of, open source ones and commercial ones. Aurora is a single Amazon Web Services native engine that happens to speak the MySQL and PostgreSQL wire protocols. 2 services, 2 very different shapes. Amazon RDS is Amazon Web Services' managed relational database service. For this video, picture RDS as 6 engines: MySQL, PostgreSQL, MariaDB, Oracle, SQL Server, and DB2. Aurora is technically part of the RDS family, but it's different enough that we'll treat it as its own thing for the rest of this video. So when we say RDS from here on, picture those 6 engines, and we'll come back to Aurora separately. What does Amazon Web Services actually do for you? Provisioning, patching, backups, failure detection, and repair. That whole layer of database operations work, gone. What stays yours? The schema and the queries. Your data model, your SQL, RDS doesn't touch those. Think of self-managed databases on EC2 as renting an apartment and doing your own plumbing. RDS is a hotel. You bring your own clothes, you arrange the room, but the staff handles the leaky pipes. Here's the catalog. 3 open source engines across the top: MySQL, PostgreSQL, and MariaDB. 3 commercial engines along the bottom: Oracle, SQL Server, and DB2. All bring your own license or paid hourly. And underneath all 6, the same Amazon Web Services responsibility band: provisioning, patching, backups, failure detection, and repair. That's the value proposition in one picture. The RDS features page lays out the managed service value prop in a single sentence. Amazon RDS handles database management tasks like provisioning, patching, backup, recovery, failure detection, and repair. That is the full list of things you stop owning the moment you move from a self-managed database on EC2 to RDS. And it works the other way too. If a scenario hands any of those responsibilities back to the customer, you're no longer looking at RDS. You're looking at someone running their own database on a virtual machine. Now the question that drives every production database decision: what happens to your database if the availability zone hosting it goes dark? Hold that question in your head, because the answer is the most important concept in this entire video. Multi-AZ is Amazon Web Services' answer. When you enable it, RDS provisions a synchronous standby in a different availability zone in the same region. Synchronous is the key word. Every committed transaction has to land in both the primary and the standby before the client gets a success back. So when the primary fails, the standby has every committed transaction. That's why your e-commerce checkout doesn't double charge a customer mid-failover. RDS detects the failure, flips the database hostname's CNAME record to point at the standby, and the application reconnects. Typical failover for a multi-AZ DB instance takes 60 to 120 seconds. The newer multi-AZ DB cluster does it in under 35 seconds. Here's what multi-AZ actually looks like. Two availability zones, A on the left and B on the right. The application talks to a CNAME, a host name, not a fixed IP. The primary in AZA serves all reads and writes, and acknowledges every commit only after the standby in AZB has it too. That's the green arrow. Synchronous replication. And critically, look at the standby. It serves nothing, zero traffic. It sits there waiting for the call to take over. Burn this into memory. The multi-AZ standby does not serve read traffic. It exists for one purpose: to be there when Amazon Web Services needs to flip the CNAME because the primary died. If a scenario says someone is using multi-AZ to offload reads, the scenario is wrong. Now meet the other RDS feature that solves a completely different problem. Read replicas are asynchronous, read-only copies of your database. Your application sends select queries, reports, dashboards, search to the replica, and that takes load off the primary. Because replication is asynchronous, the replica lags slightly behind, milliseconds usually, sometimes more. And here is the most important distinction to lock in: there is no automatic failover. If the primary dies, the replica keeps serving stale reads and nothing else happens. You can manually promote it, but that's a disaster recovery procedure, not high availability. Look at how different this picture is. The application now talks to both databases on purpose, writes "go to the primary" on the left, selects "go to the read replica" on the right. The yellow dashed arrow between them is asynchronous replication, with a slight lag built in. And along the bottom, the warning that defines this scene: no automatic failover, no CNAME flip. If the primary dies, the replica keeps serving stale reads, and a human has to step in. Amazon Web Services' own definition makes the purpose unmistakable. A read replica is a read-only copy of your database, and you point query traffic at it to reduce load on the primary. The verb in the documentation is reduce the load, not survive a failure, not provide high availability. Reduce load. Hold on to that distinction, because the next scene is where most engineers get it wrong. Here's where engineers fall over. They hear high availability, they think second copy, they pick read replica. That answer misses the mark. Multi-AZ is the right call when automatic failover is the requirement. When you hear high availability or automatic failover, the answer is multi-AZ. Here's the analogy that locks this in. Multi-AZ is a backup generator. It's wired in, it's automatic, it's dormant, and it kicks on the instant the power dies. Nobody plugs their laptop into it during normal business hours. Its only job is to keep the lights on when something goes wrong. A read replica is a second cache register opened during the lunch rush. It serves real customers all day long. But if the main register catches fire, Nobody automatically reroutes the line. The second register just keeps ringing up sandwiches at its own counter. Different jobs entirely. Now the side-by-side, line for line. Multi-AZ uses synchronous replication. Read replicas are asynchronous. The multi-AZ standby does not serve reads. The read replica absolutely does. That's its whole reason for existing. Multi-AZ gives you automatic failover via CNAME flip. Read replicas have no automatic failover at all. The purpose of multi-AZ is high availability. The purpose of read replicas is read scaling. And failover on a multi-AZ DB instance takes 60 to 120 seconds, while promoting a read replica is a manual disaster recovery action you take after something has already gone wrong. If you want it from Amazon Web Services' own mouth, here it is. A multi-AZ DB instance deployment has one standby DB instance that provides failover support, but doesn't serve read traffic. That sentence settles every argument about whether multi-AZ helps you scale reads. It doesn't. Different feature for that. Quick checkpoint. RDS gives you 6 managed engines, with Amazon Web Services handling patching and backups. Multi-AZ is a synchronous standby for automatic failover, and the standby serves no traffic. Read replicas are async copies that scale your reads but give you no automatic failover. Now we shift gears, because Amazon Web Services also offers a second relational service, a cloud-native engine built from scratch called Aurora. Amazon Aurora is Amazon Web Services' cloud-native relational engine. It speaks the MySQL and PostgreSQL wire protocols, which means your application code doesn't have to change. Your existing MySQL or PostgreSQL driver connects to Aurora the same way it connects to anything else. The performance numbers are Amazon Web Services' official claims: up to 5 times the throughput of standard MySQL, up to 3 times the throughput of standard PostgreSQL on equivalent hardware, and the durability headline you need to memorize: 6 copies of your data across 3 availability zones, by default, automatically, every time. These are the numbers Amazon Web Services itself publishes. Standard MySQL is your 1x baseline. Aurora MySQL compatible hits up to 5x on the same hardware. Standard PostgreSQL again is 1x, and Aurora PostgreSQL compatible reaches up to 3x. Same drivers, same SQL, dramatically more throughput. Memorize this phrase verbatim: 6 copies of your data across 3 availability zones. This phrase appears verbatim in Amazon Web Services documentation. It is the canonical description of Aurora storage. If you hear it, you are talking about Aurora. Here's the picture that earns the phrase: 3 availability zones, A, B, and C. On top, the compute layer. 1 writer instance in AZA, reader instances in B and C underneath all of them. A shared cluster volume. That's the architectural punchline. 6 copies of your data are scattered across the 3 AZs. 2 copies per zone. Aurora can lose 2 copies and still accept writes. It can lose 3 copies and still serve reads. Replication is automatic, it's free, and there's no switch to turn it off. Picture it like a bank. 2 safes in each of 3 buildings across the city. Even if an entire building burns down and 1 safe in another building gets robbed in the same week, your money is still accessible. That's the level of paranoia engineered into Aurora's storage layer. From the Aurora user guide, an Aurora cluster volume is a virtual database storage volume that spans multiple availability zones, with each availability zone having a copy of the DB cluster data. That word virtual is doing real work. It's one logical volume from your application's perspective, but underneath, it's spread across hundreds of storage nodes in 3 different data centers. Now here's the architectural shift that makes Aurora different. Compute and storage are separated. You have 1 writer instance and up to 15 reader instances per cluster, all of them attached to the same shared cluster volume. they don't have their own data, so when you spin up a new reader, nothing gets copied. The storage is already six-way replicated. The reader just attaches to it and starts serving queries within seconds. And those readers do double duty. They serve read traffic during normal operation, and any one of them can be promoted to writer during a failover. This is where Aurora breaks the RDS mental model. An RDS read replica uses async replication, holds its own copy of the data, exists only for read scaling, and promotion is manual and slow. An Aurora reader handles read scaling and failover, shares storage with the writer, requires zero data copying to add, and promotion is fast and built into the cluster. Same word, different behavior. Aurora readers do the job of both RDS read replicas and multi-AZ standbys at the same time. Aurora Serverless v2 is a deployment option on top of Aurora where capacity adjusts itself to load. Instead of picking an instance size, you set a minimum and a maximum measured in Aurora capacity units, ACUs. The cluster then scales in half a CU increments, all the way up to 256 ACUs, in response to real-time demand. And billing is per second, so you pay only for what you actually consume, not for a peak-sized instance running flat at 3 in the morning. Think of it as a restaurant that magically grows extra tables when a tour bus pulls up, and shrinks back to a cozy bistro when the bus leaves. You only pay rent on the tables that exist at any given moment. That's the shape of Serverless v2 billing. Where does Serverless v2 actually pay off? Flash sales and unpredictable traffic spikes, the e-commerce platform that goes from 2 ACUs baseline to 40 ACUs for a 15-minute promotion. Multi-tenant SaaS where the quiet tenants shouldn't bankroll capacity for the busy ones. Dev and test environments that sit idle for 20 hours a day, and anywhere you'd otherwise over-provision just in case. Some teams have reported significant month-over-month cost reductions after switching variable workloads onto Serverless v2. Amazon Web Services' own framing pins this down. Aurora Serverless is intended for variable or spiky workloads. With such unpredictable workloads, you might have difficulty planning when to change your database capacity. If the question stem uses the words variable, spiky, or unpredictable next to a relational workload, your answer is Serverless v2. But Serverless v2 isn't always the cheap answer. If your workload is steady and predictable, flat at the same level all day, provisioned Aurora costs less. Serverless v2 wins on variability, not on raw throughput. Don't pick it just because it sounds modern. Here's the decision tree for picking the right relational engine on Amazon Web Services. Start at the top with the engine question. If you need Oracle, SQL Server, MariaDB, or DB2, engine compatibility wins, go RDS, done. If you're on MySQL or PostgreSQL, ask the next question. Do you need extra throughput, durability, or scale? If the answer is no, you're on a moderate workload or a tight budget, RDS for MySQL or PostgreSQL is fine. If the answer is yes, you're in Aurora territory. Then one more question. Is the workload spiky or variable? Steady gets you Aurora provisioned. Spiky gets you Aurora Serverless v2. 4 scenarios. Every relational workload routed. Aurora only speaks MySQL and PostgreSQL. If the workload runs on Oracle, SQL Server, MariaDB, or DB2, Aurora is off the table entirely. The answer is RDS for that engine. Don't pick Aurora because it sounds more modern or more powerful. For those 4 engines, it's not even an option. 4 mental models to throw out. First, read replicas don't give you high availability. They lag and they won't auto-promote when the primary dies. Second, Aurora is not strictly better than RDS. It's only an option for MySQL and PostgreSQL workloads. Third, adding more Aurora readers does not add more data copies. The storage layer is already 6-way replicated whether you have 1 reader or 15. And fourth, Serverless v2 isn't automatically cheaper, it wins on variable workloads, but for steady ones, provisioned Aurora costs less. Here's the keyword cheat sheet: high availability, automatic failover, or synchronous standby. That's RDS multi-AZ offload reads, reporting queries, or scale selects. That's an RDS read replica. Any specific commercial engine name, Oracle, SQL Server, MariaDB, DB2, points to Amazon RDS, MySQL or PostgreSQL compatible with the highest throughput or durability. That's Amazon Aurora. And unpredictable, variable, or spiky next to a relational workload. That's Aurora Serverless v2. So back to Code Gorilla's 30-minute decision. For the production checkout database, RDS PostgreSQL with multi-AZ, synchronous standby, automatic failover, no double-charged customers during an AZ outage. For the month-end reporting workload that hammers the primary, add a read replica and point the analytics queries there. For a flash sale microservice with unpredictable load, Aurora Serverless v2, capacity follows the spike, billing follows the seconds. And for the legacy reporting tool that needs SQL Server, that's RDS for SQL Server, full stop. 4 different workloads, 4 different right answers, and the architect's done before the coffee gets cold. 5 things to walk away with. RDS gives you 6 managed engines, and Amazon Web Services owns patching, backups, and failover. Multi-AZ is a synchronous standby for failover, not for read traffic. Read replicas are async copies for read scaling, not for failover. Aurora stores 6 copies of your data across 3 availability zones, with up to 5x MySQL and 3x PostgreSQL throughput. And Aurora Serverless v2 is for variable or spiky workloads, scaling ACS per second. Now let's see how well that landed with a quick 5-question quiz. Alright, let's put this to work. Question 1. A company runs a production e-commerce checkout database on Amazon RDS for PostgreSQL. The team wants to ensure that if the availability zone hosting the database fails, the database automatically fails over with no manual intervention. Which RDS feature should they enable? A. Add a read replica in a second availability zone. B. Enable multi-AZ deployment with a synchronous standby. C. Increase the automated backup retention period to 35 days. Or D. Migrate the database to Aurora Serverless v2. Lock in your answer before I give it away. This one is B. Multi-AZ deployment is the canonical answer for automatic failover on a relational workload. Synchronous standby, automatic CNAME flip, no human in the loop. Read replicas are asynchronous and won't auto-promote, backups don't provide high availability, and migrating to Aurora is overkill when the existing engine already supports multi-AZ. Question 2. An analytics team's month-end reporting queries are slowing down the production RDS MySQL primary database used by the production application. The team needs to offload these heavy select queries without impacting transactional traffic. What should they implement? A. Daily snapshots restored into a separate reporting instance. B. A multi-AZ deployment so the standby can serve the reports. C. Aurora Serverless v2 with a maximum capacity of 256 ACS. Or D. An RDS read replica that the reporting tool connects to. Pause here if you want more time. The right call here is D. Read replicas exist specifically to offload select queries from the primary. Option B is the classic trap. The multi-AZ standby does not serve read traffic. Amazon Web Services states that directly in the docs. Aurora is unnecessary when a read replica solves the problem, and daily snapshot restores would give the analysts stale data and no real-time reporting capability. Question 3. A financial services customer is migrating an on-premises Oracle database with extensive PL/SQL stored procedures to Amazon Web Services. They want a managed relational database service that minimizes application changes. Which option should they choose? A. Amazon Aurora PostgreSQL compatible. B. Amazon Aurora PostgreSQL compatible with the schema conversion tool. C. Amazon RDS for Oracle. Or D. Run Oracle on EC2 with an EBS volume. Got your pick? Let's see. It has to be C, and here's why. Aurora only speaks MySQL and PostgreSQL. It's not an option for Oracle workloads at all, so A and B are out. Even with the schema conversion tool, the PL/SQL would need a rewrite into PL/PGSQL. RDS for Oracle runs the actual Oracle engine as a managed service, which means the PL/SQL stored procedures move over without a rewrite. And running Oracle on EC2 would throw away the managed service value the customer is asking for. Question 4. A business-to-business SaaS platform runs a separate database per tenant. Some tenants are quiet most of the day, while others have unpredictable, spiky workloads, including occasional onboarding events that add 10,000 users in an hour. The team wants to avoid provisioning every cluster for peak capacity. Which option fits best? A. Aurora Serverless v2. With AC/UST scaling per tenant based on actual load. B. Provisioned Aurora sized for the largest expected peak. C. RDS for MySQL multi-AZ with maximum instance size. Or D. A single shared RDS instance with one read replica per tenant. Run the decision rule from earlier before you answer. If you said A, well done. The question stem uses the exact words Amazon Web Services uses to describe serverless v2, variable, spiky, unpredictable. Each tenant cluster scales independently in half a CU increments, so quiet tenants cost almost nothing while busy ones absorb the spike. Option B wastes money provisioning for peak across every tenant. Multi-AZ addresses availability, not capacity, and read replicas don't help when the problem is sudden write load. Question 5. A company is deploying a workload that must survive the complete loss of a single data center within an Amazon Web Services region. According to the well-architected reliability pillar, what is the smallest sufficient architectural pattern to satisfy this requirement? A. A multi-AZ deployment within a single region. B. A single AZ deployment with daily snapshots to another region. C. A multi-region deployment with active-active replication. Or D. Edge locations configured with CloudFront caching. Think about which constraint matters most here. The right call here is A. An availability zone is one or more physically separate data centers within a region, and a multi-AZ deployment distributes resources across multiple AZs. That is the minimum pattern for surviving a single data center loss. Multi-region addresses a region-level failure, which is over-engineering for what this question actually asks. Single AZ with snapshots is recovery, not high availability, and edge locations are for caching content, not running databases. That's a wrap. Relational databases on Amazon Web Services, RDS and Aurora took us deep, so seriously, nice work staying with it. The next lesson brings it all together. See you there.